ongoing supervising is the 3, and completed PhD is the 4. And it is such a honor for us to have you today with us. Thank you so much for coming, ma'am. We welcome you all. Thank you. Now the session hand over to you, ma'am, please.
Thank you, ma'am.
Thank you, ma'am.
Good morning, all. So, for today's presentation, I took the topic in trends in machine learning operations. Okay. So, in this one, I'm just covering the MLOPs, why machine learning operations, who are all the people involved in the machine learning, and the machine learning model life cycle, and the key features, machine learning operations, iterations and life cycle of MLOPs, data labeling using R programming, optimization using Python. So these are all the topics which I am going to cover. Okay. So what is a machine learning? Okay. So the machine learning is a branch of computer science that focus on data and algorithm. It's enabled to AI to imitate the way human thinks, what the human thinks, the way it acts, and it's improve the accuracy. As all of you know that machine learning has supervised learning as well as unsupervised learning. So supervised learning, what we try to do is we set a label and we just would like to build a model. But in the unsupervised learning, like we don't set any label, but it is going to do the prediction accordingly. For example, you are going to group the data without labeling. You will be grouping the data. Okay. So that is what the difference between the supervised learning and the unsupervised learning, right? Okay. So in the supervised learning, some of the algorithms, you can say it as a example. For example, in the classification, you can set a label and you can able to classify. That is a supervised learning. Unsupervised learning, clustering. You can able to group the data, right? Okay. So that is what unsupervised learning. So here, it is a representation of the, for example, it is a representation of the exponential growth of the MLOPs. For example, the business we are, using the MLOPs we are using. It is mainly for the long-term value, and we are going to reduce the risk also. We are trying to reduce the risk using the data science and the machine learning methods. Okay. So because for example, you try to take a departmental store. In this one, we just use the machine learning approach we are using. Okay. So what we try to do it here is what product people will buy. That alone we are just focusing it. We are not focusing focusing the product which people who don't like that product. Okay. So in that case, we definitely we are just reducing the risk, right? Okay. So this is what uh, defining the MLOPs and its challenges. It is a simple representation of the machine learning model life cycle, which plays a major role in the MLOPs. Okay. How we do the MLOP? That is a simple machine learning model life cycle. First, you have to set the business code. So, what is the target which you are going to set it? Okay. Then you are going to access, understand, and you are going to clean the data. Okay. So first you are just trying to take the data, and you are going to analyze it, and you are going to clean the data. So cleaning in the sense, there are various things it is involved in the cleaning. For example, you are going to, remove the redundancy. If suppose one data is coming again and again, so that data you can able to remove it. You can remove the redundancy, you can able to remove it. And also sometimes there is a need for the data transformation. For example, you just take the male and female. Okay. Instead of using the male and female, what you can do is you can give M and F, or you can give 1 0, you can able to give. Okay. So similar way, you can just transform the data transformation. So data transformation in the sense, sometimes, it is very difficult to handle the large number. For example, 15,000. Okay. Instead of using it as a 15,000, you can make it as a 15K. Or instead of using it to the 35,000, you can make it to the 35K. Okay. So like this, you can able to use it. Okay. And you build the machine learning. Okay. So build a machine learning model in the sense, either you can go with the linear regression or association rules, you can form it. Okay. So that things you can able to do it. Okay. After you build the machine learning model, either you just have a linear model or you develop the association rule. Once you have done that one, you are going to deploy into the machine learning. You are just deploying, okay, the model. Okay. But you are not reaching the correct state. Afterwards, you just, you will be getting the input from the people, and when there is a need, you will be iterating the things. Again, you will be resetting the things. Okay. Sometimes, you set a business goal, so that people, okay, they will say, I have to add some more thing, but this is not at all enough. Like that, when they say, you have to again rethink that one, and again you have to build a model. Okay. So that is what you are going to do it. Okay. So ultimately, our main aim is to make a decision. Okay. So you have to set a business problem, that can be any kind of business problem, and you are going to take the proper decision, right? Okay. So first thing is, our key reasons behind the machine learning operation is, you want the original goal. You want a definite goal, you need it. Okay. And you need the proper communication between the people. Okay. And also, you are involving the data scientists or not software engineers. Okay. You are going to make the data scientists to involve in this one, but not a software engineers, right? So there are various people who is involved in the machine learning model life cycle. Okay. So in the business questions, line of business, the subject matter expert, okay, they are involved in this one. Okay. And in the developing the model, we have, data engineers, data scientists, and the subject matter experts. Okay, they are all involved in the developing the model. Okay. Then the prepare for the production is data engineer, software engineers, and ML architects. These people have been involved, and in the development to production, data engineers and the DevOps, they are involved. Monitoring and feedback loop, DevOps, they are involved in this one. Okay. So in the business question, first they have to set up the business goal. Okay. So related with their business, what is the business? What is their business? Based on that one, they have to set up a goal. Okay. So then, so here in the developing the model, we have, data acquisition. So we just, accessing the data. Which data you want, we are accessing it. Okay. And when you access the data, we'll be having, many columns are there, or many attributes are there. So in this attributes, for example, 100 attributes are there. The 100 attributes may not be, fit for our data or our model. Okay. So in this one, maybe the 20 may be one which is relevant for our relevant to build a model. So in that case, you have to take that 20 alone, you have to take it. Okay. Then you have to train the model. Okay. So after you have selected the features, you have to, train the model. Okay. So after once when you trained it, okay, after you have selected the feature, you can train using the or the classification, any of the things you are using, and you are going to the model. When you build the model, when using n number of once when you evaluate the model, okay, so if there is an improvement, you are going to improve the things. That's what will happen in the monitoring and the feedback. Okay. So after evaluation, the model is going to the production department. It is going. Okay. There, they will be, measuring the risk. What are all the risk they'll be checking, and the runtime environment. Okay. So that also they are checking. Okay. In their environment, the model will run or not, they'll be checking. Okay. Once this is over, that will come to an development to production. Okay. It comes to the production. Okay. So in the elastic scaling is nothing but, so according to our data or according to our environment, our model has to scale. For example, for the 100 students are there, we created the model. Okay. So then it goes to the 10,000 students. So our model has to be scaled accordingly. Okay. Then containerization. Okay. So in this one, it should, adopt all the infrastructure into a container. Okay. Then integration and the development. Okay.
இதுல நிறைய பேர் போடாம இருக்கு.
So afterwards, monitoring and the feedback loop. Okay. So in the monitoring, the whoever is the people logging on to the system, so that they are,
உகேந்திரன்
like
யாருடா?
உகேந்திரன் அங்கதான் இருக்கான். என்னாச்சு?
trying to
அங்கீதானே?
ஆமா.
வனிதா,
வனிதா
வர்ஷா
வீட்ல
போடல.
வீரபுத்தி போட்டிருக்கான்.
trying to keep track all the people who is, there.
விஸ்வநேசன் அவன் போடல.
அவெல்லாம் வரவே இல்லை.
சிவசுப்பிரமணியன்
சிவசுப்ரமணியனா?
அப்புறம் சிவா
So the next thing is the
அதுதான்
input
அவங்க
drift
வந்து வேற இதுல
tracking. Okay. So input
கொஞ்சம் போட சொல்றாங்க
நான்
ஷீட்ல
அந்த
சென்ட்
ஷீட்ல
பண்ணணும். ஆமா
எந்த ஷீட்ல
இந்த ஷீட்ல
இந்த
தான்.
ஷீட்
Sumi ma'am,
நம்பர் இருக்கா?
என்ன ஷீட்
நீ சேவ்
Sumi
பண்ணிருக்க.
hello. Sumi ma'am, kindly mute your audio. Dear participants, kindly mute your audios.
ஏடா சிவராஜுக்கு சென்ட் பண்ணிடுறேன். அவனை சொல்லி போட சொல்லிடுறியா? அவன் நம்பர் இருக்கு.
ஒரு 3200
Uttumar sir,
எப்போவாலும் இங்க கொண்டே வர மாட்டேன்.
maybe the host can mute the people. Muthukumar sir.
Ma'am?
Sir, you can mute the other people, sir. If you are a host, you can mute the other people.
Sorry, ma'am.
Okay. So logging and alerting, where whoever is the people who is logging into the system, their record has been saved, and it is for the further analysis. Then input drift tracking is nothing but there is a sudden change in the input. Okay, that is a drift. That is a input drift. For example, a student is performing well in the class. Okay, but suddenly he is not performing. Okay, so that is a input drift tracking. Then performance drift. The model is performing well. Okay, but suddenly there is a drift in the performance. Then you will be having the online evaluation. Okay, finally you are evaluating the things.
ஏயா பியா
Okay, so when you
தேர்ட் இயர் தானடா? இந்த லீட் கோட் ஃபுல்லா ஃபினிஷ் பண்ணிட்டீங்களா? அன்னைக்கு அனுப்பியிருந்தாங்களா ஸ்ப்ரெட் ஷீட், அதில் போட்டு விட்டீங்களா? ஹை மீடியம் எல்லாம் நிறைய பேர் போடாம இருக்கீங்க.
so when you are going to get the feedback from the after monitoring, you are going to get the feedback from the people, and you are going to improve your model. Okay, so we'll be seeing that terms
ஏன் வசந்தங்க
one by one.
ஐவி கேன்சல்
So
தான் நினைக்கிறேன்.
elastic scaling is the ability to automatically adjust the amount of resources based on the demand. Okay,
ஐவி கேன்சல் தான்.
suppose your system want for the 100 people, it has to give. If it wanted to give for the 1000, it has to give it for the 1000. Okay, so then containerization, that is a virtual technology, so that packages an application component into a single portable container image. Everything will be put in a single portable container image. Then continuous integration and continuous delivery. Okay, so there multiple changes are made to a code base simultaneously. We are changing the system and we are integrating the things, and it is going to the delivery. Okay, this is usually for the software is quickly and efficiently we are doing the things. Okay, so data acquisition is the real world signal to the digital signal. Actually, data acquisition is nothing but you go to the library. Okay, there you are just giving your ID card. Okay, so when it takes the input of your ID card. Okay, so you take all your details is coming to the system. Okay, that is whatever it is from your ID card, that is going to a digital. Okay, feature engineering, so that is the raw data into the features. Okay, so you will be having your own data. That raw data you are going to putting into features. Okay. For example, so I just say a name. Okay. So Alvin went to the department. Okay. In at 9 o'clock, like that I'm saying. Okay. So there, the features are, name of the student is a feature. Okay. Where he went, which department he went, which date he went. Okay. So that is the raw data you are putting into a features. Then, as I have told you, drift monitoring. Okay. So drift monitoring is a it is not like usual things. Something unusual happens. Okay. Somewhere, there is a sudden drift, sudden traffic, in the changes. The performance will be good. So, but immediately, the performance may not be good. For example, usually, when we see, the students' performance, plus two students, okay, he may got 10th, he may have good, marks, but suddenly in the 12th, he may not have good marks. Some may be there, other reasons may be there. Okay, so that is drift monitoring. Okay, so and um, QA in production. Okay, so whenever to collect the data, question answer is one of the way of collecting the data. Okay, so in this one, awareness, whoever is collecting the question answer or whatever the questions which has been put there, it has to be um, related with an environment. Okay. So then DevOps is a combination of software development and operations. It deals with both the software development and the operation. Okay. So it is going to integrate the work of development teams and the operation team. Okay. So it is a development team and the operation team. Both have the collaboration and the responsibility. Okay. So, so here, there are many tools are there, tools and the practices that increases the organization ability to deliver the application and services at high velocity. Okay, because of the DevOps, we are just providing the high deliver the application and services at high velocity. Okay. So I have told you many things about the drift. So I'm not telling you again. Okay. Then, so here, there is a automation is needed. Okay. So recently, we developed one of the things, one of the exercises, auto ML system, that it does everything automatically. Okay. So that is a robust automation is needed in the machine learning. Okay. So and everywhere the communication is, we want the best communication. Okay, best communication we needed, and you have to build the system, and you have to test it and release it. Okay, as you know, you are in the second day of the FTP. Actually, in the first day yesterday, one madam took about the all the things, machine learning, supervised learning, unsupervised learning, everything she took it. Okay, so in the basic things here is, we will be having the training data and we'll be having the test data. Okay. So and the model. Okay. So training data, for example, 150 data is there, 100 is the training data. So 100 you are going to take it and you are going to train the things, and 50 you are going to use it to test the things. Okay. So and whatever the model we build it, the accuracy is important. Okay. always, we try to take, above 60, we are just, we are accepting the model. Okay. So, and prioritizing continuous delivery. Okay, we just, when there is a requirement to change, you change it and you are going to deliver it. Okay. So, you just, should have the heterogeneous environment and a framework for MLOP's best practices. Okay. So MLOP practice heterogeneous environment in the sense, it can be applied for any element, maybe in case of financial risk. Okay. So in the case of anti-fraud, can apply. So, how yes, and okay, continue your answers. So continuously you have to monitor and you have to adjust the system. Okay. So risk assessment. Okay. So sometimes, model is unavailable for a given period of time. Okay. So certain period of time the model may not be available, or certain samples the model will be giving the worst prediction. It may give the worst prediction. Okay. And the model accuracy may be, decreased. Okay. The accuracy may not be, good, right? Okay. So like, the data scientist who is, involving or in that, particular model. Okay. So they may not have the necessary skill. Okay. They may not have the necessary skill. Okay. These are all the reasons for the risk assessment. Okay. So risk mitigation. Okay. Actually, always the model has to be a standardized one. So if I develop a model for a university, it should cover all the southern university. Okay. So that is what, the standardization is important. Okay. And the performance of the machine learning model is also important. Okay. Then it is very sensitive to the production environment. Okay. So what the people want, that things it has to give. Okay, not an extra one. It has to give exactly what the people needed. And open source software. Okay. So always, we have to go with the open source system, right? Okay. Okay. So the model has to be, explainable by human. So if I have a particular model, so I have to explain what it is. Okay. And the accountability. So I should believe that the particular model is, accountable. Okay. So MLOP is for the scale. Okay. So actually, when I build a model, I'll be giving a versioning, version 1, version 2, like that, I'll be giving. Okay. So if I go with the next version, the model performance has to be improved. Okay, from version 1 to I'm just going to the version 1.1. Okay, so in that case, the rather than comparatively with the previous version, this version has to be, giving the better thing it has to give. Okay, but it should not degrade the production. Okay, production should not, be degraded. So there are different roles of the peoples are the subject matter experts. Okay. So what they have to do is they should have a role of key performance indicator. Okay. What is the goal? They have to define it very clearly. Okay. And MLOP's requirement here is they have to deploy the model for the business terms. Okay, they have to give good performance model, they have to give. Okay, and the once when they give the model, they should get the feedback and they have to improve the things. Next one is a data scientist. Okay, so the scientist, so they can be properly used in the production environment with the production data. Okay, and they should have to assess the model quality. Okay, whether the model is having the good quality, they should assess it. Okay, so here the MLOP's requirement is automated model packaging and delivery for quick and easy deployment to production. They should give a quick packaging and delivery of the particular model. Okay, and also ability to develop the test also they have to develop. And the third one is the data engineer. Okay, so they have to optimize the retrieval and the use of the data. Okay, so optimization is nothing but best results it has to give. For example, you just take the route, different route. Okay, different route. For example, I'm just taking the route from Tirunelveli to Thoothukudi. Okay, so there are different routes will be there, but the best optimization result is shortest route is the best optimization result. So the next thing is the data engineers. Okay, so optimize the retrieval and the data to our ML model, optimizing the retrieval. Okay, so and the MLOP requirement here is the performance of all the deployed model. Okay, so and the performance has to be improved here. Then the software engineers. Okay, so the software engineer it integrate the ML models in the company's applications and the system. Okay, so they'll be integrating the ML model for the particular company or particular university. And here in the MLOP requirements is versioning and the automatic test. Versioning is nothing but here maybe for a particular company, the old version may be best. That times you can use the old version. Then DevOps. Okay, so they conduct and build the operational system and test for the security, performance, and availability. Okay, they are conducting and building the operational system. Okay, Actually, this team is, the integration between the development and the operation. Okay. So here MLOP recommends is, integration of MLOPs into the larger DevOps strategy for the enterprise. So here we would like to go with the enterprise. We'd like to go with the enterprise. Okay. So the next thing is the model risk manager. Okay. And auditor. Okay. So so here, as auditor, ensure the compliance. Compliance is nothing but standard. Really, the model has the standard. Okay. So MLOP's requirements here is, um, it is automated. It is automated and reporting tools on all model. Okay. So always, the things has to be automated and reporting tools on all models has to be, produced, right? Then machine learning architecture, okay, ensure the scalable and flexible environment to for a model. So when an university for 200 students, this has to work. 5,000 students, it will work. Even for the 10,000 students, it has to work. Okay. So high level MLOP requires high level overview of models and their resources consumed. Okay. So here, high level overview of models and their resources has to be consumed here. Okay. So as we have elaborately we have seen about the subject matter expert. So they are just dealing with the goals and the business question they are using. So main thing is, they should have the proper decision making. Okay. Proper decision making, we would like to arrive using the machine learning model. And our model, whatever the model which we just go with, should give a proper prediction. Okay. So these people, subject matter experts, should have the feedback mechanism also they should have, right? So the next one is the data scientist. Okay. So they in the data scientist, so they should have the technical skills they want. Okay. And they have to gather the data, prepare the data, and explore the data. In the preparation, they should go with the data cleaning. Okay. And data transformation, you have to go. Okay. So that things you have to go, right? Okay. So the next thing is the data engineers. Okay. They are focusing on the database. Okay, database like Oracle, MySQL, like that database they are focusing. They manage the flow of data. Okay. So and optimize the retrieval. They should optimize the retrieval. When we access the data, the optimization has to be used. And it should give good performance of all models deployed in production. Good performance has to be given. So the next thing is, software engineers. Okay. So they produce the ML model. Okay. And they work with the data scientists. Okay. So they will be, responsible for the maintenance of the website. They will be responsible for the maintenance of the web, and the performance has to be improved. Okay. Then automated testing also they have to give. So as I have already told you, they want the combination of development and the operation. Okay. So the main thing is it increase the efficiency, speed, and the security. is increasing. Okay. So we are going to build the operation system to ensure the security. Okay. In order to ensure the security, we build the operational system. Okay. So continuous integration and continuous deployment, as I have told you, continuously we just collect the data, collect the feedback, and we improve the system. We are deploying the system. Okay. Then the model risk manager and the auditor. Okay. So actually, their main aim is they should, have a standard regulatory compliance. They should have it. Okay. So actually, uh, any department or any university or any company, they'll be having the audit for the uh, 1 year period. Okay. So, what is the use of this audit is to maintain the standard. Okay. The same way, our ML model also has to go with the auditing to have the, to maintain the quality of the model. Okay. Then machine learning architect. Okay. So he should, meet the requirement for the data needs from across the business. So the entire business, what is the requirements is needed, that to be, that he has to take care. Okay. So he should take care of how data is stored, how we are accessing the data. Okay. So, and so scalability has to be maintained. Even they should introduce the new technologies. For example, there is a new algorithm came from rather than the existing algorithm. For example, decision tree is a old one. So based on the decision tree, we have developed one more algorithm, random forest. It plays the major role in predicting the things. So what they can do is they can suggest the random forest to the situation. Okay. So they should have a centralized view of resource allocation, and always they have to check with the long term improvement only they have to check. Okay. So the next thing is we are going to talk about the um, key MLOP features. Okay. So always, machine learning, to identify the patterns. Okay. We just in a teaching field, those who are, people going to the class, we just, categorize the student based on the pattern. Okay. Slow learner, medium learner, and the, high quality based learner. So like this, we analyze the people and we identify the things. The same way in the data also, we have to analyze and you have to identify the pattern. Okay. So actually in the machine learning model, there are three to four things are very, very important. First, you should have the training data. Then you should have the testing data. Then you will be having the model, predicting the model you will be having. Then finally you will be having the validation. So you just take the training data and we are going to build a model. Okay. So, and you are going to check the model with the test data. Okay. So finally, you are validating with the, various measurements like accuracy, F score, okay, recall, like that, the various measures we are using it. Okay. How the machine learning works. Okay. You are inputting the data and you are going to analyze the data and then you find the pattern. Okay. And we are going to predict it and the feedback is stored here. Okay. So, for example, we just take our admission. Okay, from one area, our admission is good. Okay, in the previous year. Okay, so we can just collect the feedback. Okay, so collect the feedback and you can try to improve the model. Okay, so this is what about the machine learning working. Okay, so there are types of machine learning algorithms are there. So as I have already told you, there are two classifications: supervised learning and the unsupervised learning. Supervised learning, we just use the labels we are using it. Okay. So labels we are using it and we are predicting it. Unsupervised learning is, we are not using the label. Okay. So, linear regression and, the classification and all, it is an example for the supervised learning. And, clustering is an example for the unsupervised learning. Okay. So, as you know about the decision tree, it classify based on the tree. Okay. So you'll be taking the right decision by splitting with the tree. Okay. And you take the neural networks. Neural networks, it's work like, human brain. How the human brain is working, the same way neural networks will work. Okay. So how to select the algorithm for the MLOPs? First of all, the performance and the efficiency and scalability in production. These are all the terms you have to consider to select an algorithm. Okay, whether the performance is good, whether the algorithm will work efficiently, and it will be it is whether it is scalable. Okay, so that things you have to consider. Okay, so in the model training, deployment, monitoring, and the maintenance. Okay. So, as I have already told you, the key terms training, testing, model building, evaluation, these and all, the very, very important in the machine learning. Okay. Apart from that, you have to deploy the model and you have to monitor the model. When there is a deviation, you have to maintain it. Okay. So these things you have to take care in the algorithm selections on MLOPs. Okay. So so there is a smooth transition and efficient management in the production has to be there. Smooth transition is nothing but sometimes what the people will do is they'll be running the old system as well as new system parallelly they will be running. Okay. So once people have been adopted for the new system, what they will do is, they will be removing the old system. Okay. So the smooth transition is important. Okay. So the people will not accept the new system as it is. Okay. So that is that things you have to consider. Okay. From the old one to new one, you have to, slowly and steadily you have to bring it out. Okay. So the next one is the introduction to ML model development. So we have seen about the data preparation. Okay, in this one, I have told you data cleaning and the data transformations occurs. Data cleaning is nothing but removing the redundant data, and you are avoiding the missing values you are avoiding. Okay. So and the transformation is, as I have told you an example as male and female is there. So that things you can take it as a 0 and 1. So the next one is the feature extraction. 100 features may be there. but only 20 may be relevant for us. That things you have to take it. Okay. Then the model.
ரெக்கார்டிங் இன் ப்ராக்ரஸ் தான், ஆனா அப்பப்போ வெடி வெடியே போயிருக்கு.
Model training and the testing. Okay. So that things already I have discussed you. At last, you are coming with the prediction. Okay. So the model has been built. Okay. So once the model has been built, we are testing the model by giving the input. When there is any deviation, you are trying to rebuild the model. Okay. So we are talking many things about the machine learning, but ultimate aim of the machine learning is, objective of our business, whether it works for our educational institution, whether it works for any company. Okay. So their objective, whether it's satisfying. Okay. So that things has to be, we have to define it very clearly. Okay. So the data sources and EDA, exploratory data analysis. Okay. So data sources, from where we collect the data, that is very, very important. Okay. Sometimes, when you collect the data with the social networking, so you'll be, your model will be improved. So you have to, check which data sources may be suitable. Okay. Up to the data mining and machine learning, it doesn't have any limitation about this data has to be taken from the relational database. From anywhere, any format, you can able to take the data. Okay. So feature engineering and selection. Okay. So, so here, the feature engineering, properly you have to clean the data and properly you have to select the features you have to select it. Okay. So, and the ultimate thing is our model has to be, have, proper accuracy has to be there for our model. Okay. So, we just train the model. Then after training, the model is created. You would like to check with the accuracy of the system. Okay. How you will check the accuracy of the system is, there are, different things, evaluation techniques you can use it. Okay. F score. Okay. Or R squared you can use it. Recall you can use it, So like this, different techniques you can use it. Okay. So reproducibility. Okay, as I have told you, the model will be having the different version. Okay. Once, sometimes we feel like, you have to go with the next version. Okay. Next updated one. Okay. Then you'll be going with the reproducing the model. Okay. And you are going with the next version you are going. Okay. So the next thing is, responsible AI. Okay. So we should have a proper understanding about the model behavior, testing, and the execution results. I have the model, but if I don't know how the model is working, or if I don't know, what is the result, what is the use of it. Okay. So, and the proper documentation is also needed. Okay. And the model decision, the fairness and mitigating the bias. Fairness has to be there. Okay. So the common techniques here is, plots, subpopulation analysis, what if analysis. Okay, that and all, common techniques here. MLOP practice. Practice nothing but real time where you are applying. Okay, maybe if possible, I'll discuss about the MLOP practice in the credit score if there is a time. Okay, so you are applying to the real time. That is the MLOP practice. Okay, so easily you have to deploy the things and you have to monitor the things and you have to maintain the model. Okay, and our ultimate aim is to long term success only. That's not small term success. Our ultimate aim is long term success. Okay, so productionalization and the deployment. Okay, so actually, when you deploy the model for the production, okay, so any new product or any new models, people will not accept it immediately. Okay, so the proper collaboration has to be there between the data scientists, software engineers, and the DevOps teams. Okay, so sometimes delay or failures. Okay, to deploy are inevitable. Okay, sometimes there may be some delay will be there, some failure may be there. Okay, but we have to correct it with the proper feedback. Okay, so this is what training code, labeled data, and the model building. Okay, so label data in the sense, we are just, using the input, whatever the input here you are using, you are going to give a label. Okay. So 1, 2, 3 like that, you can give it and you can just go with the model building. Okay. So finally, you are building a model with the web app code we are deploying. Okay. So deploying into production. Okay. So there are two common deployment types are there, deployment types and the content. So model as a service, live scoring model, it is deployed as a REST API for real-time request. Okay, this is model as a service. It's like Google Cloud. We just provide that one. Then embedded model. Okay, so here packaged into a application for batch scoring request. Okay, so you give it as a package into an application for batch scoring. Okay. Deployed model typically include Python or Java and the data artifact. Okay. So whenever we build a model, the dependency has to be reduced. Then containerization. Okay. So it solves dependency issues with lightweight self-contained environment. Okay. Docker is the one which allows the application to exact model requirements. If you want particular model requirements, this Docker will provide you. Okay. So the next thing is the blue-green deployment techniques. Blue-green is nothing. We are going to give two separate things. That is, old one also will run and new one also will run. I can, both the things we want the infrastructure. Okay. So that is what, blue green deployment techniques. Okay. So the elastic scaling use multiple container managed by technologies like Kubernetes. So elastic scaling, whenever you need extra resources, it is going to provide you. Okay. So the Kubernetes are providing that one. Okay. So orchestration is, it is a process of automation. This is used in both cloud on-premise environment. Both the things it is used. Okay. So model deployment requirements. Okay. So here, you have to ensure the coding, documentation, and the standards of the model you have to take care. Okay. Then second thing is you have to recreate, revalidate the model in the production environment. You have to validate the model. Okay. So, and the third one is perform explainability checks and meet the governance requirements, whether it meets the governance requirements. Okay. The fourth one is, check the quality of the data has to be checked. Okay. The finally embed into the application with integration test. You are going to embed with the application in the integration test. So, the importance of continuous performance and monitoring. Okay. So, any model, when it performs, you have to monitor it continuously. Okay. So, there are different stakeholders are there, DevOps, data scientists, and business have unique concern. So, DevOps will see the model in a different angle. Data scientists will see the model in a different angle. Business people will see the model in a different angle. Ultimately, you have to ensure the model effective things and valuable over time. Okay. So DevOps concern is, they want speed and the resource usage. They want, the resource usage has to be improved and the speed has to be improved. Okay. And memory and the processing use has to be sensible, and they want scalability. Okay. So, and they have to expertise and applicable to manage the ML model. They have to be expertise. Okay. Business concern. So mainly, business people, what they will do is they will be, seeing, justifying its cost. Okay, whether the cost is reduced or not, they will be justifying. Okay. Then monitor the key performance indicator. Whatever they asked. Okay. So whatever, they were, the company asked whether it's satisfied, the model is satisfying that one. Okay. So, and they'll be, evaluating the ML contribution specifically, right? Okay, they are using the rule-based model to evaluate the ML contribution specifically. So machine learning operations. So MLOP has a set of practices that deploy and maintain the machine learning model. That is practically for any application, you can develop that one. Okay. So it actually combines the principle of DevOps with machine learning. Okay. So machine learning to ensure the integration, deployment, monitoring, and the data management of ML model. Okay. So when you compare this MLOPs and the DevOps, both emphasize automation. Both want automation, collaboration, and interactive environment. Proper communication is needed. Okay. So they have some of the unique challenges in the ML model development and the deployment. Okay. So as you know, we have machine learning model it is mainly, decision decision making and the pattern identification. You are using the machine learning model. Okay, you are using that one. There are various models we are using. Regression, linear regression, you can use it. In the classification, you can use the Bayesian classification, decision tree, that and all, the classification methods, you can use it. Okay. So here, the life cycle of MLOP, first you have to consider the data preparation, how you are going to take the relevant data. That means, how you clean the data. Okay. How you are avoiding the missed values. Okay. So, and what you are using it for the training and what you are using it for the testing and all, you have to consider. Okay. Then you have to train the model, implement the proof of concept for the ML model. Okay. So this is demonstrate the feasibility of a proposed product method. Okay. So you are applying different ML algorithms and perform data engineering and the model engineering, and you are going to deliver the high quality model you are going to deliver. Okay. So model evaluation, the holdout test. Okay. So in the holdout test, that is nothing but, you can able to test the model with, every data, or randomly you can pick some data and you can test it. That is what, holdout test set. Okay. So if suppose, 50 records, you take it as a test data. One by one, you can take it and you can test, or randomly some 10 to 20, you can take it and you can just, check it. Okay. So metrics calculations. So there are different measurement you can use: accuracy, precision, recall, F1 score and all you can calculate. Okay. Then baseline comparison. Baseline comparison is nothing but always, we'll be having some, baseline. This model has to work for, like, uh, for example, I'm just training my student at least to get 50 percentage mark. That is a baseline. Okay. So at least that has to be met by a particular model. Okay. So then threshold tuning, then optimize the performance. Baseline is 50, you are going to optimize into a better performance. Okay. After you trained and test the model, you are going to deploy the model. So it is going for the production. Okay. So the real time it is applicable for the incoming data. Okay. So what and all you have to consider during the deployment is scalability. You have to consider the model has to scale. When even, the organization grows, the model has to scale, and you have to monitor the data. Monitor the data. Security has to be, taken care, and versioning. Okay, I am just using 1.1 version means, I have to, know about all the things. So I should not provide the one version infrastructure to 1.1. Proper versioning has to be maintained. Then model monitoring. Okay. So you have to detect the drift. Okay. Sometimes the drastic change in the input data. Sometimes, the drastic change in the performance. Okay. So that has to be monitored. Okay. So monitored. Okay. So and it has to come to the production. Okay. So the tool has to be, remain accurate and reliable. Okay. So The model has to be reliable for the future use. Okay. Then the model has to be maintained. Okay. Monitor incoming data for the changes in the distribution. For example, before 5 years, students, the behavior is different. Now the behavior is different. Accordingly, the model has to be changed. Okay. And exactly proper target label has to be fixed. Okay. The target label, which is, suitable for our system, has to be fixed. Okay. So the drift has to be properly identified. This is another good concept, retraining. So regularly update the model with fresh data. That is, every time the new data is coming, the model has to be updated. Okay. So automated retraining has to be done based on the schedules or the triggers. Okay. And the concept drift handling. Okay. So, as I have told you, the sudden change in the input data, that is the input drift. Okay, a student performs well in the 10th standard, but 12th standard he didn't perform. So, there is a sudden change. Okay, so and you are going to retrain and fine tune the models to maintain the accuracy. The next one is the model versioning. Okay. This year, maybe I'm just producing version 1 model. Next, year 1.1. So, proper versioning has to be, incorporated. Okay. I should not confuse with the version. And some of the tools they are using to have the centralized repository like DVC and ML flows that they are using to ensure the traceability and reproducibility. Okay. Then governance. Okay. Governance is nothing but MLOP combines DevOps practices with machine learning workflows. Okay. So governance is nothing but we are going to provide a software system. Okay. So it contains the DevOps practices and the machine learning workflow. That is the development and the operation, as well as machine learning workflows they are using. Okay. They have to use proper compliance standards. Transparency has to be there. Okay. Any times when I see the model, I have to say this is the output. This is the way it works. Like that, it has to say. Okay. So it involves process to control the access, track interaction, and the document model foundation. Okay. So you have to control the access, interaction, and the document model foundation. Challenges. Okay. So many companies overlook model governance until deployment. Okay. So we would like to have a software system. For example, we have our university have one system. Okay. So the entire student community and the staffs they are using that one. That is a governance. Okay. That deployed and it is a great use for all the people. Okay. So here the standard has to be there in the system and no risk has to be there. Okay. And you have to go with the AI specific regulation because nowadays ChatGPT has a major help to everyone. Okay. So we have to go with the AI specific regulations. We have to go. Okay. So the developing the model, already I have told you, you are taking the input data, you are going to train the data, and you are going to build the model. And if suppose 150, our 150 rows are there, 100 you take it as a training data, 50 you take it as a test data, and you build the model. Okay. So the data, whenever the data, when we take it, we cannot take the entire data. The relevant data has to be taken. Okay. So different algorithms you can use it. Okay, any like association rule mining, or Bayesian classification, decision tree, like that you can use a different algorithm. But ultimate thing is our model should give the best performance, optimize the model performance. Okay. So establish the communication, system integration, and the pipeline integration. Okay. So you have to manage and track the model. Finally, you monitor the model, and when there is a deviation, you can just uh, you can build retrain the model. Again, you can build the model. So there is another concept, data labeling. Sir, continue பண்ணலாமா? Muthukumar sir,
Yes, ma'am.
shall I continue or shall I stop?
Now the time is 11:40.
Hmm.
Tomorrow also, are you coming, ma'am?
Yes, madam. Morning session.
Okay, ma'am. We will conclude it. Then tomorrow we will continue the session.
Okay.
Okay, ma'am. Thank you.
Okay. Thank you all for your patient listening. So thank you so much.
Thank you, ma'am. We will continue on tomorrow's session. Thank you, participants. We will join at 2 o'clock. Thank you.
Thank you, ma'am.